Alright, so today we're going to start on page 83 and be dilating lines. Okay? Our objective for today on page 83 is to dilate lines on the coordinate plane. Okay? So, the best way for me to teach you how to do this is to show you how to do this. So, we're going to start with the line y equals 1/2 x plus 2. So, I'm going to graph that line. And this is the great thing about having graph paper as our notes. So if you notice, I'm graphing this really fast, and here's a brief lowdown of how to graph this really fast. Okay, I have it in the form y equals mx plus b. This is my y-intercept. This is my slope.
Andrea, please come to the main office. Andrea, it's the main office.
So I start on the y-axis at 2, and I move up 1 over 2, or up 1 right 2, in the positive direction 2. So slope, remember, is rise over run. So I've got this line. And I'll label it. Okay. I'm going to dilate it a couple of different ways. Okay? First, I'm going to dilate y equals 1/2 x plus 2 with respect to the center of dilation. -3, 4, and a scale factor of 3. So, what I'm going to do is I'm going to kind of do the same thing that I did with a construction. I'm going to first mark where my center of dilation is. So 1, 2, 3, 1, 2, 3, 4. Okay. And now I'm going to pick 2 points on my line that I'm going to use as my dilation points. So I'm going to take as my straight edge, and I've got this handy dandy post-it that I'm going to use as a straight edge because it just needs to be straight. It doesn't need to be a ruler or anything. Okay. And I'm going to pick 2 points that I'm going to use to dilate. I'm going to pick this point right here, and I'm going to pick this point right here. So I'm going to dilate, here's my center of dilation, -3, 4. And I'm going to draw that line right straight through. Okay. I have to dilate this with a scale factor of 3. So this is going to be kind of large. But the ideal is I want to count over from the center to the pre-image. So I'm going to count, I have to go 1, 2, 3, 4, 5 to the right and down 1 to get to this point right here. So starting at the center of dilation, I need to do that 3 times because that's my scale factor. So 1, 2, 3, 4, 5, down 1. There's 1. 1, 2, 3, 4, 5, down 1. There's 2. 1, 2, 3, 4, 5. Oh, did I do that right? I guess I'm just a little bit off. Maybe I'm just a little bit off, but it should be. Yeah, I'm a little bit off. It should be right on this line somewhere. As you can see, I was a little bit off, but it was close. Okay, so that's where this point gets dilated to? Way out here. So I need another point. So I'm going to dilate through this point. So to get to this point, I have to count 1, 2, 3 down and 1 to the right. 1, 2, 3 down and 1. So I have to go back 1, 2, 3 down, and I have to do that 3 times from the center of dilation. 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. I'm still a little bit off of my line, but the line gives me an idea of where it needs to be. I'm pretty close. I did it 3 times. That's where it should be. Now, I'm going to need a larger straight edge to make my line, but here I go anyways. So now, I need the equation of this new line. So one thing that I do know about this line is that the slope stays the same because dilations preserve. I wonder if you can fill that in before I do. What do dilations preserve? Do you remember? They preserve parallelism. So the slope is going to stay the same. So when I write the new image, the slope stays the same. It stays 1/2 x, up 1 over 2, up 1 over 2. Now I just have to figure out where does it cross the y-axis to finish out this equation. 1, 2, 3, 4, 5. -5 is where it crosses. So this is the image of this line after a dilation with a scale factor of 3. That's really cool. Okay, let's try another one. Let's dilate y equals -2 x plus 1 with a scale factor of 1/2 and a center of dilation of -2, -1. Let's try that. Okay, so I'm going to draw my axes. Draw my little graph here. So +1, that's the b value. -2 means the slope is -2 over 1, which means I'm going to go down 2 and right 1. Down 2 and right 1. Down 2. Remember, when I'm graphing slope, I have to pause. Hold on, it might be a little bit weird when I come back. Alright, so I think I'm okay. I'll double check the video though and make sure that I am okay. So I gotta graph this line. Okay. Label it. Now I'm going to mark where my center of dilation is. So it's 2, -1. I'm going to change that. I'm going to change my mind. Make it 2, +1. For the sake of making my life a little bit easier one here. So 2, +1. Okay. Now, I'm going to pick 2 points to do this through. And honestly, I can see a nice little right triangle here to pick. So, draw it through the center of dilation, the pre-image, and I'm going to pick this point down here, this point up here, because it makes kind of a nice little straight up and down right angle. Easy for me to count. So, dilation of 1/2 means I'm only going to go halfway in between. So, I have to count 1, 2, halfway of that is 1. I have to get down to this point. I have to count 1, 2, 3, 4. Half of that is 2. So there's my new image. Oh, this is pretty. Much prettier than previously expected. The slope stays the same. And where does it cross the y-axis? At 1, 2, 3. So there's the image. So this is how we dilate a line on the coordinate plane. Here's my, make sure I mark this, 2, 1, center. That's it. That's how we do it. That's all I got. If the center of dilation is actually on the line stays the same. So I guess we should write that down. If the center of dilation is on the line's image is the same as the pre-image. Remember, the length of the line isn't going to change because the line goes on forever and infinitely, and 5 times infinity is still infinity, so it doesn't much matter. That's it.